Right. Welcome to Southwest Tennessee Community College weather class, the April 13th lecture, part 1, where we're covering the tropical and arid climates. All right. Hopefully you guys make sure that, again, you've got your study guide printed out. There's a lot of the vocabulary words and the key things are already on here, so you can just follow along. All right, so quick review. We talked about the major climate classifications last week, and we know that with the exception of the arid climates, which are the yellow on this map, all the rest of them have a latitudinal base because they're initially based on temperatures. So you're going to have the warmer tropical climates within the tropics, then you're going to have the more temperate climates in the mid-latitudes, and then you're going to have the colder climates in the upper high latitudes, and then you're going to have, of course, the super cold polar climates at the poles. But today we're going to be breaking down the major climates into their more, or even more, what I call them subclimates. They are a little more specific and picky, and this is where the precipitation amounts are going to come into play, and so the actual climate map gets a little more complicated here. But we're going to break it down just one major climate at a time and make it pretty simple for you right here. So the first one we're going to be talking about are the tropical climates. Now in your textbook or a textbook or on Google, you can find the location maps for just the tropical climates. Again, it stands out very clearly. It's right within the tropics that we have here, all right? And the different topics that we have here, there's 3 of them. We have tropical rainforest climates, we have tropical monsoon climates, and we have tropical savanna climates. And the difference between those 3 is going to be their precipitation amounts and also precipitation patterns. So the very first one we're going to talk about is the rainforest. And as the name implies, these are very forested areas with a lot of trees. Where you're going to find these is right around the equator. This is the area that is having, is usually under the influence of the equatorial trough or the doldrums or the ITCZ. You guys might remember this from when we talked about the air pressure and the subsequent wind belts that we find on the planet. So that's what this is. So right around the equator, always under the influence of that low pressure. Low pressure, we know, lets you have adiabatic cooling, which means you can get clouds and you can get rain. So the rainforests are getting rain all year round. They pretty much get rain every single day, and most of it's in just good old convectional thunderstorms that pop up late in the afternoon. So these places are warm year round. They have lots of heat, lots of humidity. Always have lots of insulation. The sunshine's coming in at a direct angle because it's in the toward the equator. That is there. Day and night pretty much stays the same all year round. It doesn't, 12 hours a day, 12 hours a night, varying just by an hour or so the further away from the equator that you get. Annual temperature ranges in these places are going to be extremely small. Temperature is not going to change much throughout the whole year. All right. Most of these rainforests will receive at least 80 inches of rain a year. Some of them exceed 200 inches of rain a year. Put that in terms you guys can understand. 80 inches is 7 feet of rain. 200 inches is about 18 feet of rain. So the tropical rainforests, where do we find them? Again, we find them on the equators. All right. So here are the big famous rainforests that you find right here in South America. All right, based around the Amazon River, we have the Amazon rainforest. This is actually the largest one in the world. All right, you follow over to Africa, the same location right here on the equator, based right around the Congo River. All right, we have the Congo rainforest right here in the central part of Africa. All right, continue on, and we get into the rainforests here of basically Indonesia, all these islands down here, Borneo, which is part of Indonesia, these areas, Malaysia, the Philippines, and we have scattered rainforest throughout Southeast Asia here as well. All right. There's a few places that you can find, especially over here in Central America, all right, and in some of the islands of the Caribbean. We have small pockets of small rainforest area that's around over here. All right. So let's talk about the plants in the rainforest. Of course, I know you guys have heard the term rainforest before. What these forests are, these are evergreen trees, but they're not like the pine trees that we usually think of evergreen. They're broadleaved. The best example I can give you that you're probably familiar with is the magnolia tree, which, you know, they stay green all year round, but they've got the big wide leaves that go on, and that's what these trees are like. There's a few pics from your textbook. All right, so you've got lots and lots and lots and lots and lots of trees. These trees are extremely tall, go up for hundreds of feet high, and all the green tree tops, we refer to that as the canopy. All right, and what's unique is in these areas where they stay green all the time, and as you can see, the canopy and the leaves are very thick, so very little sunshine actually makes it down to the floor of the rainforest, and it's quite clear down there because it's almost perpetually dark. During the daytime, it's just going to look like twilight because so much of the sunlight is filtered out up high above. So down here on the forest floor, it's actually quite clear. It's easy to walk around. This is very different from the term jungle that you might have heard of. But the rainforests, they're known as a selva, all right, which is different from a jungle. A jungle is going to occur where sunlight can actually make it down to the forest floor. So in areas of, you know, like along riverbeds, or maybe if there's been a clearing of some kind, and you get lots of little saplings and vines and stuff that grow up and that you would actually need a machete to hack your way through. That's what we think of as a jungle. These are not. These are selva with a wide open space underneath that goes on. Now, lots of life is found in the rainforest, huge diversity of both plant life and animal life. Lots and most of the animal life lives up high in the canopy. There's many, it's like a multi-story apartment building. You got folks and birds and bugs and stuff and monkeys that live at the very tippy tops. Then you've got other folks that live kind of mid range up in the leaves and stuff. And then, yes, you do have a few things that live down in the understory. Again, lots of bugs are part of that. There are snakes as well. But most of the big life that stays up above. In these, you don't have the really big, giant predators that you see too often and stuff like this. Now, something that is unique about these rainforests, now they have taken over 1 million years to actually grow. And what happens is these areas suck when it comes time to, if you actually want to do real commercial style agriculture. And the reason for that is that forest floor is not really dirt. The dirt is buried underneath 6 to 8 to 12, 20 feet of what is called a root mat. Just over the thousands of years, when you have, you know, dead leaves that do fall down, or occasional dead trees that do fall down, and dead monkeys and dead birds and things like this that don't get eaten up. And you've got this thick organic mat down at the bottom that is built up. Give you a good idea for this, if you've ever walked underneath, you've got a little grove of pine trees or something like this in your backyard, and all the pine trees fall down and you walk around on it. You hadn't cleaned out the pine needles in a few years and it's all spongy and squishy. That's often what the floor of these selvas are like. And that's where all the nutrients are. They have done experiments where they've literally poured water down into that and find that hardly any of it even makes it down into the actual soil. It's all redistributed through the root mats. And so what happens is, now if you're an indigenous person who live in small villages, maybe 40 people or something like this, you can do what's called slash and burn agriculture, which is very simple. You go in and take a small area about the size of an acre, and you do cut down the trees, you know, get down to the soil, but the soil, again, has no nutrients in it. All the organic with all the nutrients is up above in that root mat. So you've got to put some nutrients back into the soil. So you do that by burning, hence the name slash and burn, all right? So that puts a little bit of nutrients back into the soil. Now, what they plant in these small areas is, number one, native plants. And they also make use of the area very, very well. They'll plant a cornstalk, which grows up nice and tall. Then they will plant beans, all right, which will use the cornstalk to wrap around and support itself. Those beans do put some nutrients back in the soil. Then they'll plant other crops, like maybe some yams or something like this, that need to be in a little more shade. And so they'll plant them at the very bottom, underneath the beans and underneath the corn. And so you're utilizing the space very well. These areas are going to be good and fertile for maybe about a year or two before all the nutrients, which there were hardly any there to begin with anyway, are used up. Now, then they'll pick up and move on and slash and burn another small acre some other place away. That one open acre, it can usually recover. Now, it's going to take tens and thousands, hundreds of years before you get, again, 200-story trees that are flowing up in there. But that's no big deal. The problems that we're seeing in all these areas, okay, in all of the major rainforests of the world, is commercial deforestation, where they're trying, they cut down these trees, they burn them up, and they want to do the one single monocrops. Big one of them is palm oil, what they go on. And this is bad because they are cutting down these trees. They're, taking away the habitat of a zillion animals, destroying zillions of plants, lots that we get medicines from. We don't even know, heck, the cure for COVID-19 could be in a rainforest, and we've cut down the last of the trees that contain the fungus that holds the ant, that has the goo that could be the cure, and it gets burned and destroyed forever. But huge, hundreds and thousands of acres are being burned in all these areas for these commercials. Again, soil is crap. It doesn't have any nutrient in it, so they have to spend lots of money to put, fertilizer and stuff like this on it. And then again, after a few years, it doesn't last very long, and they have to move on to more, and then you just leave this barren ground. And it's not home to monkeys or anything else anymore. One of the animals that is extremely threatened and endangered now lives right over here in the island of Borneo, where those are their orangutans, all right, our giant ape cousins, and they are extremely threatened by deforestation. Of course, the burning is adding carbon to the air, so this is increasing our greenhouse gases, so that is a big problem in and of itself as well, all right? So, human issues causing problems in the rainforests, all right? So, now, the monsoons, all right? These look very similar initially, the same forest that you would find in a regular rainforest, except a monsoon climate has a short little dry season, all right? And the reason for that, it's due to the shifting SWTCC. Remember, we know that this scenario right here would be on an equinox when the direct ray of the sun is hitting right at the equator, but we know that these pressure belts are going to be shifting with the seasons. All right, and if you're in an area that part of the year you're under the influence of the the SWTCC, and then you become under the influence of some of those trade winds, that's where we have monsoons, where you have those shifting winds, where the winds may come from the south, and then the winds come from the north, and then you've also got the SWTCC and stuff like this. Now we know that monsoon is strictly a wind term, but in some places, we had mentioned this before, we have the wet monsoon, where the shifting wind, let me find a back for this, all right, where the land configuration, you might guys remember this, we looked at this as talking about the Asian monsoon that becomes a wet monsoon because you have when the wind's coming from the south, all right, warm, wet wind because it's blowing over the oceans, it hits mountains that are here in Southeast Asia, okay, along the western coasts of India and around all the mountain ranges that we see here in Myanmar and Thailand, Laos, Vietnam, and areas like this, all right? And we know what happens when warm, wet air hits a mountain. It's forced to rise and can cause clouds and lead to rain. And in these monsoon areas where they have, again, the wet monsoon, so again, we're talking Southeast Asia over here, they have huge amounts of rain. And to be totally honest, we're not 100% positive why it gets quite as much rain as it does. Here in the western mountains, they're called the Ghats mountains here on the western coast of India, they can get over 22 feet of rain a year. That's a lot of rain. But one thing that's different is because of the shifting of the monsoon, it's only going to be raining when the winds are coming out of the south and blowing up. All right? During the part of the year when the winds have shifted and our dry winds coming out of Asia, those are going to be clear skies. It's going to be cooler, slightly cooler temps, which means high pressure, which means no clouds. You've got stable air, no clouds. And so they do have a switching system. Let me back to this little picture right here. All right, this is called a climograph, but this is rain. So it's showing the rainfall throughout the year, and you can see you have, just a little bit of rain, and then you've got 4 months of a heck of a lot of rain, and then it peters off again. All right. So this is the typical pattern that you will see, these big surge in rain for a few months. That is typical of these monsoon forests that go into monsoon climates. There aren't that many places that have these monsoon climates, all right? Basically, pretty much concentrated here in Southeast Asia, all right? Now, the people that live here are very used to all the rains that they get and also the cycling of the rains. They prepare for those. I know you've seen lots of pictures of the Indian monsoons, where houses are flooded and streets are flooded and everybody's just walking around like it's totally normal. And it is normal. They expect that in every year, and the fact they want it because the rains bring the life, and it brings water for the crops and things like this. Now, there is a crop that thrives in flooded fields. Okay, it doesn't care if it's got wet feet at all, and that is rice. You're probably used to seeing pictures of rice paddies and stuff like this. Well, rice is native to this area, and it grows very well. And it's not that, this is what's kind of unique. Rice itself doesn't necessarily need to grow in a flooded field. It's just that it doesn't care if the field is flooded, which is very different from most plants, because if you flood most plants, they're going to croak and die. All right, so the rice is extremely well adapted to the characteristics, the rainfall characteristics of a monsoon climate. And the folks for thousands of years that live in these areas have taken advantage of that. They, again, these are mountainous regions. That's one of the reasons they're getting so much rain. And they've cut flat terraces up into these mountains. And that's where, are basically the fields for the rice. So when it does rain, they do flood. And again, it acts as a perfect weed control system, because any other funky plants you don't want in there are going to drown, and the rice are going to go great. And on top of that, in addition to growing all this rice, which is a great basic staple, all right, of course, what likes little flooded lakes and stuff? Waterfowl, ducks and geese. So people will also raise ducks and geese because they can just let them swim around in the rice paddies. They don't have to feed these because, of course, they're going to be eating some of the rice. They're not going to eat the whole entire crop, just enough. But what goes in has got to come out, and so the little duckies are swimming around. They are pooping. They are making great fertilizer for the rice. And then at the end of the season, not only can you harvest all the rice for your family and extra to take to market, you've got a whole flock of fat geese and ducks that you can also use for dinner and also take to market. Many of these places also will have fish that they will grow and eat in these areas. So it's a really unique, symbiotic relationship that folks have built up for that as well. All right, so that's the monsoons that go on. One thing about all these tropical climates, even though we're used to talking about summer and winter months, obviously in tropical climates where it stays warm all year round, you don't really have summer, winter temperatures at all. So they will often refer to high sun and low sun. High sun is their summer, when the sun is going to be at the highest point up in the sky, and in some places literally straight up and down. And then the low sun is going to be in the other months when the sun is just a little bit hot, not straight up and down, just a little bit off. All right, and that's often the the different seasons that go on. So you'll hear high sun and low sun when we're talking about that type of stuff. All right, so, okay, let me switch around my notes, make sure I stay on track here. All right, Savannah is the last tropical subclimate we're going to talk about. This is one that has a very extremely distinct wet season and dry season. Their wet season, it's going to look and feel like a rainforest. They're going to get so much rain. But the dry season is going to be like one of the steppes. And the wet and dry seasons last several months each time. It can dry out. You would think you're in the middle of a desert during the dry season. Here in the savannas, you have very different plant types of life. Here it is open grasslands with scatterings of trees. A lot of times the trees are the acacia trees. I know you've seen this. All you got to do is Google your typical African photo, and you're going to see a great shot of either an elephant or a giraffe that's in silhouette with the setting sun, and then you've got a few little silhouettes of trees and then a bunch of wide open spaces. And if you've ever seen The Lion King, you know what we mean by the savanna. All right, so the savanna is going to be totally switching between both the ITCZ and the high sun area, which is going to be the rainy seasons. All right, and then the subtropical highs in the low season. Sorry, you probably can't see that. All right, so the subtropical highs as we shift back and forth. All right, so the savannas are, whoops, we're losing our tilt here. Savannas are going to be on the outer edges, more toward the actual Tropic of Cancer's, Tropic of Capricorn lines. So in Africa, which has actually the largest savanna climate areas on the planet, we see those in East Africa over here. This is where the Serengeti is, which that's Lion King, okay? That goes on over here. And what's the Serengeti is a national park here in Tanzania and Kenya, where we have the largest migration of large herd animals, all your antelopes, your giraffes, your zebras, all right? And then also the predators that do follow those as well. But they're constantly following the cycle of the, they're trying to find, follow the rain, all right? So, because that makes the grass grow, which they then eat and do around. We have, a few other areas that have savanna as well, but this is the largest area. Now, over here in South America, we also have the savanna climate, but they call it a different term. Savanna is the big generic term. Let me write this one down for you. There, it goes by the name of the Llanos, which is the Spanish name for the savanna, or in Brazil, where they speak Portuguese, they call it the Cerrado. All right, so here are the two, Llanos and Cerrado. All right, but it's a savanna. It's the exact same term thing. The area is not near as vast as you will see in Africa, and they don't really have the big native animals, not the, the big giant herd animals that we see in Africa, we don't see in South America. In fact, I think like the biggest animal they've got on the savannas in South America over here are the giant anteaters, all right, which aren't really, they're only a predator if you're a termite, and then you don't, or an ant. You don't have to worry about those. All right. Now, soil here, you do not, now, you don't see much agriculture in the savanna, in these areas. And that is because the soil type in the dry season, I mean, it's actually a little similar to ours here in the Memphis area. And see if you've ever tried to plant a tree or plant a garden, but initially, we've got a lot of clay in our soils. Same thing with these guys. In the dry season, it is as hard as a brick. You cannot dig down. In fact, they literally do make bricks out of this soil, all right? They can cut bricks out of it and build houses with it. That's what adobe is, all right? Then in the wintertime, when they get all the rains, it turns into this sticky, gooey muck, which you can't even get it off your shovel, which again, if you've ever tried to dig a hole here in Memphis on a day like today, we know what that's like as well. So it really sucks for digging agriculture. Now, obviously, with all these big open grasslands, now these grasses are clumpy grasses. Think of an area that just has crabgrass instead of Bermuda or zoysia lawn, just those clumpy crabgrass around. That's pretty much what it's like. You've got like space in between. And again, keep in mind, you do have these copses of trees. You've got scattered trees here and there, lots of wide open spaces, but you still see the trees. This is an important deal when we compare it with another grassland we'll talk about in the arids. So anyway, it's great for grazing. Now, you still do not see any kind of commercial grazing of both cattle or sheep or anything like this, large scale plantation ranch style in Africa. And the reason for that is this little bug called the tsetse fly, which carries the sleeping disease. And this is deadly for domesticated animals. They will not survive. They will waste away and they will die, which is not very good. And obviously there's not either a vaccine or bug spray or something like this. The native animals, the antelopes and everything, are used to it. It's kind of like with us just having a little bit of a cold. It doesn't bother them at all. But the more domesticated critters, it will wipe out. So you will not see any type of commercial ranching and grazing on the lands in Africa. All right, you can see teeny tiny small scale, again, with villages and things like this, but not on a large scale. However, in South America, they do not have the tsetse fly. And so a lot of the llanos and the cerrado is actually used for both horses and cattle and I guess sheep. I honestly don't know, but it can be used for that. It's still not very good for agriculture though, as far as plants, crops, or growing crops or anything like that you will find. All right. Now the problem with any of these savanna climates that you find here and about is that they can be overgrazed. All right. As I mentioned, huge migration of the animals, of the wildebeest and the zebras and the antelopes. And so they hit one area, they graze there for a few days, and then they move out, and the area can grow back. But if you start blocking off borders, as we have a tendency to do as humans, if you confine animals to a small little area, they will overgraze and stomp down the grass as well, and it may not be able to recover. And we'll talk some more about this again in some arid climates. But you have to be careful with that type of thing as it goes on. All right, so that is our tropical climates. So we're going to go on to our arid climates. Now the arid climates are a little bit different. As we know, they're based strictly on precipitation alone, okay? temperatures are relevant. You have hot deserts, you have cold deserts, you have ones that are hot in the summer and cold in the winter. All right, doesn't matter. It's just the lack of rainfall that they get. Now, I'm going to explain to you how we decide whether a place is a arid climate versus a more humid climate. All right, all the other climates are considered humid because they end up with an excess amount of rainfall at the year's end, where you do have permanent rivers, you've got permanent lakes, water's there all the time. That's considered a humid climate. What's different about the arid is you don't. So just kind of listen, get the gist of this. You're not going to have to do this on your own or anything like this. But it goes back to a term we've had before called evapotranspiration. Remember, this is how water vapor gets into the atmosphere, all right, through evaporation of standing water or ice, as the case may be, and also transpiration, which was that process that plants do, all right? So in determining if a location is arid or not, we have to look at what's called potential evapotranspiration. We want to see, based on the temperature of the air, which, the warmer it is, the bigger the rates of evaporation you can have. And of course, the more plants you have in an area, the bigger amount, more water the plants will need to suck up and then also respire out or transpire out in that process. The best way to explain this is I want you to imagine that there is a football team of 20 members, all right? And after a game, these guys are hungry. And to be just basic satisfied, full, as in, okay, I'm full, each guy needs one large pizza, all right? So imagine that after the first game, they all go back to the locker room and area, and whoever's delivering the pizzas brings 3 pizzas. All right? These guys are not going to be, these 20 guys are not going to be satisfied at all. All right? They are, their potential potential pizza eating and hunger satiation needs to be 20. All right? So 1 large pizza for every guy. You only bring 3, you're not going to meet those needs at all. There's not going to be any pizza left over, and there's not going to be enough pizza to make them happy. They're all going to be extremely hangry, all right? That would be like a desert, all right? Getting, it needs a whole lot. It needs, 20 pizzas worth of water, and it only gets 3, all right? If you brought in 19 pizzas for the guys to eat, they would probably, close enough, they'd be happy. They're like, okay, we're full. At least they wouldn't be hangry, all right? There's still not going to be any pizzas left over at all. They're all going to get eaten up, and, but again, they're more or less satisfied. This is going to be around the range of what we call the steppe climates, where you get a little more rain, you can actually have a little more plants in the area, but you still don't have any leftover water. You don't have permanent lakes or big rivers or anything like this. Now, imagine that you brought in 40 pizzas for these 20 guys, all right? They're gonna, they're probably gonna eat up, at least, they eat at least 20, might eat a little few more, but chances are you're gonna have a lot of pizzas left over for tomorrow. That is a regular humid climate, which could be any of the others, okay? So when we're talking the arid climates, we're talking about the area not getting enough pizza to satisfy themselves, okay? So, all right, we find arid climates all over the place, all right? They do not follow, here we go, any type of latitudinal pattern, so to speak. You can see they're scattered just about at every single latitude, all right? And we do have two categories. We have the desert, which is the driest, and then we have the steppe, which gets a little more rain, all right, enough to support grasslands, but that's about it. You're not going to see any trees, and again, you're not going to see any permanent lakes or anything like this, okay? Now, why, if it's not latitude that is deeming you to be an arid climate, what is it? Well, there are actually multiple reasons for this. Now, keep in mind, and this goes for all climate classifications, you've always got to be keeping in mind the elements of weather and the controls of weather. Okay, these are the very things we talked about way at the beginning of the semester. All right, and it's the interaction between all of these that affect your weather, which in turn are going to affect your climate. So keeping all these variables in mind and how they're going to interact with one another and influence the other one is going to be always in your mind when we're talking about climates. What is it about a location that turns it, in this case, dry, not to get a lot of rain? Well, there's multiple reasons for that. I'm just going to kind of list them out really quick and then give you guys some examples of all of them. Number one, might be an area that is dominated by high pressure. All right, we have seasonal and permanent high pressure systems that we find, again, going back to the pressure belts that go on. And high pressure has stable air, which has clear skies, which means no rain. All right. We know that locations smack dab in the middle of a continent, far away from any large bodies of water, you don't have any water source. So you're going to be drier there. So you've got that going on. We talked about rain shadows. When you've got mountains like we see down here in South America, all right? When you've got warm, wet air, hits the windward side of the mountain, all the water's squeezed out on the one side, and then the air that descends on the other side is very dry, and it's warm, and it acts like a giant hair dryer and blows, dries everything out. So we've got that rain shadow version that goes on. Some places go back and actually are connected to ocean currents. Remember when we talked about that during the last test? We've got all these different ocean currents that go on, all right? And a good example of what can happen when you have a cold ocean current running along beside of you, all right? If we look to Namibia, I'll say it right, all right? Down here in Africa, there is a cold current flowing up along the side over here, all right? The wind blows with the westerlies, blows this way. It's a warm wind. It's got plenty of moisture in it because it's blowing over the ocean, and then it hits this cold patch where the cold ocean current is. And so, we did this when we were talking about advection fog. All of, the air can condense right there where it gets cold, and you get lots of fog. And then as the wind continues to blow, it's now a dry wind because literally all the moisture got squeezed out here in the ocean. And so by the time it hits the land, it's very dry. So the Namibian desert is one of the driest places on the planet. All right. Another location that is a combination of factors, that exact same situation with the wind blowing and, hitting the cold Humboldt current along the western shores of South America. But on top of that, in this area, a part of Chile right up here, it's dominated by the high pressure, okay, those horse latitudes that we see right around the Tropic of Capricorn here. And there we have the Atacama Desert, which is literally the driest place on the planet. Since they've been, paying attention to it and trying to record, it's been over 100 years, like 120 years, and they've never had any rainfall or snowfall or anything here in the Atacama Desert. all right? Now, some other places is still related to wind. Over here along the eastern coast of Africa, especially around Somalia and these areas up here, the winds are blowing parallel. They're coming down this direction. And so they're blowing parallel to the coastline. So instead of blowing moisture from the ocean onto the land, the wind's coming this way, blowing over all this land area, never picks up any moisture. All right, and so it's very dry there. So even though it's right on the coast, it can still be a desert. Good example of the rain shadow was down here. Again, it's in Argentina, dealing with the Andes Mountains. The back side, the leeward side, we have Patagonia, which is a very famous desert, rain shadow type desert. We get a little bit of rain shadow deserts up here in North America and, our southwestern versions. There's a lot of mountain ranges that flow through here. There's the Sierras, Nevadas and stuff like this, and there's multiple other ranges. And here's a little combination of lots of things. We've got some rain shadow stuff going on because we know we got rain flowing or winds blowing this way. We've got the fact that it's getting kind of mid-continental, all right, far away from any water sources, and also the fact that a very, kind of a high pressure system sets up here in the summertime as well and acts over that. So it's a double whammy. That's why we have the Chihuahua Desert, the Sonoran Deserts, where our Death Valley is, all these deserts in this area over here. The biggest desert in the world is also, it's a little bit of combination factors as well. We've got right here on the Tropic of Cancer, so that high pressure belt that we see around here. We've got mid-continent, and we also have, if any winds are coming this way, they don't pick up a whole lot of moisture from the Mediterranean here. This is the Sahara, all right? Notice I do not say the Sahara Desert because the word Sahara is just Arabic for desert. So if you say Sahara Desert, you're saying the desert. So it's the Sahara, all right, which is the largest. We also have mid-continental and also dealing with dry winds blowing in, the whole Arabian Desert in this area, and then all throughout what we call the Middle East, Iran and Afghanistan. These are a lot of either, deserts or the steppe lands, which we'll talk about in a little bit. Up here in Mongolia, we have the Gobi Desert, which is one of the biggest, or not biggest desert, but it is a very mid-continental desert that we see. And Australia as well, all right? Big Australian desert. The outback, as they refer. We have a lot of desert lands that are here, all right? So those are just a few of the big deserts to be familiar with that goes on. And the reasons for those are dry lands, I should be saying, not just strictly deserts that go on. So, again, the desert is the one that's going to be getting the absolute least amount of rain, or the lowest, rain for its potential evapotranspiration. It is not based on a actual, number of inches per year. Okay, that's one thing that the Köppen classification system does not do. And so it's again based on potential evapotranspiration. It's not, there's no cutoff that says, well, if it gets 2 inches of rain or less a year, it's automatically a desert. There are some climate classifications that will use that, but not Köppen and not us. Okay. Now, desert climates, they can be hot temperatures, they can be cold temperatures, they can be low elevations, they can be high elevations. But one thing they all have in common with the lack of clouds, because of the lack of water vapor in the air, over 90% of insolation will make it down to the surface in these areas. If you will recall, when we were talking about the whole planet as a whole, less than half of insolation made it down to the surface. It was either reflected back or absorbed higher up or scattered or something like this. because clouds are a big reflector of sunlight, but desert areas don't have clouds. Therefore, the sunlight can pour on in. So 90% insolation often reaches the ground, all right? So it's no surprise that usually the highest temperatures on the planet are found in these desert locations. The record belongs to Death Valley. It was recorded back in, actually, didn't they just, I think they just broke it. Did I make some notes on that? Now I've got to go look that up. I completely forgot about that. But usually the record, it goes back, let me look at my notes specifically. I think we've talked about this before. It was like back in 1924 or something like this, and it was like, I think 135 degrees. All right, it was, yeah, it's really hot. It got really, really hot there. So that's no surprise. In Egypt, it can be 85 degrees in the shade, but 110 in the sun, but the soil itself can be 200 degrees Fahrenheit. It's getting so much that goes on. One thing that we do have in a desert, now it might have, I mean, it's annual temperature range when you're looking at a summertime high versus a wintertime low. It could be small, it could be really big. It just depends on its latitude, it depends on its elevation. Well, there's lots of things. However, one thing that you will find is the daily temperature range, okay, is huge. It's going to have the largest daily temperature range of any of the climates. It can be up to a 72 degree daily temperature range. So that would imagine that it gets down to 0 degrees, 0 degrees Fahrenheit at night, but all the way up to 72 during the day, and then shifts down again. So we think our weather's bad, like it has been lately, where it was, 80 degrees 2 days ago, or whenever it was. You're out in shorts, everybody's out in shorts, and then it's freezing again. And I'm back, I'm back in a sweater and got my sweats on. Can't make up our mind. Well, this happens like every day in a lot of these deserts. All right, and that's because with the lack of water vapor in the air, we know water vapor itself is one of the greenhouse gases, but at night, no cloud cover, no water vapor, all the heat is going to rise and escape out into outer space. That's the reason it's going to get so cold. All right, and then with the sun coming in, by late afternoon, temperatures are going to rise up because all of it comes in, heats up the ground, which starts to heat up the air, and it goes on. All right. All right. One thing in deserts, there's a lot of convection currents with that heat, afternoon heating going on. And so oftentimes the deserts can be quite windy, right? Little gusty winds, especially picking up in the afternoon and stuff like this. Plants, your typical type of desert plants. The name is called xerophytic. You don't have to know that. It just means that they have very unique ways of maintaining what little moisture that may fall. All right, of course you're familiar with cactus, all right, that have those very waxy coatings on the outside. They have like spongy layers inside that will hold on to what little water they get, and so they can last a long time without water. There's a creosote bush, which you may not be familiar with the plant, but it's sap because it's toxic. If you've ever been around where they were installing some brand new railroad ties or putting up a new telephone pole, and it's got that sticky kind of tar coating on it that smells really astringent and kind of funky, that is the creosote sap, which is actually toxic to other plants and to bugs, because the creosote extrudes this out of their roots, literally poisons the ground right around outside of them. So no other plants or no other bugs is going to steal away what little moisture they might be available to them. It's how they hog their own water. It's pretty cool with areas like this. Any animals that live in desert areas tend to be nocturnal because it's too hot oftentimes to go out at night. So they can come out when it's cooler, and also when the temps are cooler, you might have a better chance at getting maybe some dew forming, as if the dew point is reached, which often can In fact, in some of these areas, that's the only moisture they get is dew in the morning, all right, because the temperatures have dropped down to the dew point enough, all right. A lot of the animals that live in these areas do not even drink water. Some of them will have, it's a type of tern. It's a bird, lives in the Andes areas and stuff like this, and they literally have a gland that can remove salt out of salt water so they can actually drink salt water. Other animals, literally especially some of the, say like snakes and things like this, the only moisture they get is the blood from the animals that they prey upon, all right? And then other critters are, able to survive well, and they, again, they eat cactus or something like this to get their moisture. So, many of them do not actually lap up any type of water because there is no water sitting around for them to lap up. Now, the other category under arid is called the stepplands. These are always going to be transitions. They get a little bit, these are the ones that get the 19 and 20 pizzas, all right? So there's, a little bit more rainfall, enough to support lots and lots of grasses, but no big, water suckers like bushes or trees or anything like this. But they are a transition zone. You're always going to be finding stepplands in between a desert and a much more wet climate. So, for example, here in the Sahara, in between the Sahara Desert and the Congo rainforest, you're going to find stepplands. You're going to find these big, wide, open grasslands. Now, these grasses are very different from the savanna grasses. These grasses cover, thickly across the whole ground. Their roots go down very, 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 very deep because, of course, they're looking for possible water way down deep. And this makes for a very fertile soil and an easily tilled soil as long as you can cut through all those roots, all right? So sahels are very nice. And this is called the Sahel here in Africa, but the stepplands, you will see lots of grazing, and they, if managed correctly, they can have some agriculture as well. In the U.S. are the prairie lands, the Great Plains that literally run all through, down into Mexico, through Texas, into Oklahoma and Kansas, parts of Colorado, the Dakotas, all the way up into Alberta and Manitoba, up here in Canada, is all dry steppe lands. We call them prairies, all right? But it's the exact same type of thing. You'll see some down in South America, all right, between the Patagonia area and then the rainforest areas. You'll see that there, all right? Hang on, let me swap out, make sure I'm hitting all the right stuff. All right. And in Mongolia, most of Mongolia, if it's not the Gobi Desert, which is down here toward the south, then it's all stepplands through there. We see lots of stepplands all through this parts of South Asia, Russia, Kazakhstan, and areas like this. And these grasslands also are great for grazing as well. Horses originated on the stepplands, all right, and we're brought into that. Our big grazers, native grazers, are the bison and pronghorn, which are actually goats, not antelope. So we see those over here as well. Just like we've got lots of ranching with sheep and cattle and horses and stuff within our areas, you'll see that in South America as well, and theirs, and then lots of herding and everything that goes on in Asia as well, plus Africa, Sahel regions and stuff like this, all right? Australia has a lot of stepplands as well. They're big with sheep. They do ranch a lot of sheep on those stepplands as well, okay? So now you have to be careful with both grazing and if you do farm, all right, on these areas, you've got to practice good soil conservation because if you don't, these are very fragile lands. If you overgraze them, if you plant crops that won't thrive and then the crops die, but you've dug up all the grass, these big high winds that often in these wide open places, the winds are going to be blowing, will literally blow the soil away. And it will turn something that was a steppe land and convert it into a desert. And that can't come back. This is called desertification, and it is a huge problem. We had issues with it here in our areas, Oklahoma and stuff, during the Dust Bowl area of the 1930s due to really poor farming practices. We're seeing it happen in the Sahel region of Africa. The Sahara is expanding due not necessarily to changes in precipitation patterns, but to overuse of these steppe lands by humans, by confining their grazing animals in a small area. So they eat all the grasses up, they pound down the ground into a hard pan so new things can't grow up. Think about, across lawns where people have walked and you've got that dirt path that no plants will grow up through because it's so packed hard. That can happen in these areas as well. China's got issues with it all up here as well. So desertification is a major issue. It increases aerosols within, the atmosphere. Those aerosols can travel from China all the way over to the United States. They can travel from Africa all the way over to South America and Central America. And while a little bit of that is, of course, natural, the amounts have been jacked up very high. It can be a major issue that goes on. All right. That, I do believe, is it. All right. We will end there with the arid climates for this section. Again, look up all these areas, look up these words on Google. Look at pictures. Look at all the different types of deserts that you can see. There are sand seas, there are rocky deserts. See what I mean by the prairie lands and stuff like that. So be sure to look these up. And again, we'll stop here for a break and I'll be back very shortly with the mesothermal and microthermal climates.